Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about Bravais lattice, and the main topic is crystallography. Bravais lattice refers to the 14 different three-dimensional configurations into which atoms can be arranged in crystals. The smallest group of symmetrically aligned atoms which can be repeated in an array to make up the entire crystal is called a unit cell. There are several ways to describe a lattice. The most fundamental description is known as the Bravais lattice. In words, a Bravais lattice is an array of discrete points with an arrangement and orientation that look exactly the same from any of the discrete points. That is, the lattice points are indistinguishable from one another. Thus, a Bravais lattice can refer to one of the 14 different types of unit cells that a crystal structure can be made up of. These lattices are named after the French physicist Auguste Bravais. 14 types of Bravais lattices. Out of 14 types of Bravais lattices, some 7 types of Bravais lattices in 3-dimensional space are listed in this subsection. Note that the letters A, B and C have been used to denote the dimensions of the unit cells, whereas the letters alpha, beta and gamma denote the corresponding angles in the unit cells. Number 1. Cubic systems. In Bravais lattices with cube systems, the following relationships can be observed. A is equal to B is equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degree. The 3 possible types of cubic cells have been illustrated below. Simple cubic, body-centered unit cell, body-centered cubic unit cell and face-centered cubic unit cell. These 3 possible cubic Bravais lattices are primitive or simple cubic cell P, body-centered cubic cell I, and face-centered cubic cell F. Examples: polonium has a simple cubic structure, iron has a body-centered cubic structure, and copper has a face-centered cubic structure. Number 2. Orthorhombic systems. The Bravais lattices with orthorhombic systems obey the following equations. A is not equal to B is not equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degree. The 4 types of orthorhombic systems: simple, base-centered, face-centered and body-centered orthorhombic cells. Simple cubic, base-centered cubic unit cell, body-centered cubic unit cell and face-centered cubic unit cell. Examples of orthorhombic systems: Rhombic sulfur has a simple orthorhombic structure. Magnesium sulfate heptahydrate, that is MgSO4 7H2O, is made up of a base-centered orthorhombic structure. Potassium nitrate has a structure which is body-centered orthorhombic. An example of a substance with a face-centered orthorhombic structure is barium sulfate. Number 3, tetragonal systems. In tetragonal Bravais lattices, the following relations are observed. A is equal to B is not equal to C, and alpha is equal to beta is equal to gamma is 90 degree. The two types of tetragonal systems are simple tetragonal cell and body-centered tetragonal cells. Simple and body-centered. A is not equal to C. Examples of tetragonal Bravais lattices are stannic oxide, simple tetragonal, and titanium dioxide, body-centered tetragonal. Number 4, monoclinic systems. Bravais lattices having monoclinic systems obey the following relations. A is not equal to B is not equal to C, and beta is equal to gamma is equal to 90 degree, and alpha is not equal to 90 degree. The two possible types of monoclinic systems are primitive and base-centered monoclinic cells. Primitive and base-centered monoclinic cells. Cubic cells are monoclinic sulfur simple monoclinic and sodium sulfate decahydrate base-centered monoclinic. Triclinic system. There exists only one type of triclinic Bravais lattice, which is a primitive cell. It obeys the following relationship. A is not equal to B is not equal to C, and alpha is not equal to beta is not equal to gamma and is not equal to 90 degree. An illustration of a simple triclinic cell is given below. Such unit cells are found in the structure of potassium dichromate. Its chemical formula is K2Cr2O7. Rhombohedral system. Only the primitive unit cell for a rhombohedral system exists. Its cell relation is given by A is equal to B is equal to C, and alpha is equal to beta is equal to gamma is not equal to 90 degree. An illustration of the primitive rhombohedral cell. Alpha is equal to beta is equal to gamma is not equal to 90 degree. Calcite and sodium nitrate are made up of simple rhombohedral unit cells. Now, hexagonal system. The only type of hexagonal Bravais lattice is the simple hexagonal cell. It has the following relations between cell size and angle. A is equal to B is not equal to C. Alpha is equal to beta is equal to 90 degree and gamma is equal to 120 degree. An illustration of a simple hexagonal cell is where A is not equal to C. Zinc oxide and beryllium oxide are made up of simple hexagonal unit cells. Thus, it can be noted that all 14 possible Bravais lattices differ in their cell length and angle relationships. It is important to keep in mind that the Bravais lattice is not always the same as the crystal lattice. Thank you very much. Like, share and subscribe my channel Science Kick. Allah Hafiz.